and I will share my screen. Cool. Welcome everyone, and happy to see everyone back. Uh, Unfortunately, we couldn't do that in person. Our previous edition was in person, and it was awesome. I really like it to really get to know each other and do the network. Then COVID hit us again, and yeah, we had to move back online. So we just had the luck to do uh, one in-person edition. Looks like now in March we're gonna go back to in-person. So hopefully that solves our issue. But while we are online, we can use that in our advantage. So today we have Yuri that is currently living in Germany, and Alex that is in Quebec. So like pretty um, far from us. So we can take advantage of that. Um, if you are in the call, most probably you already joined. But if you are watching this, because I'm recording the the meetup, please join us on community.cncf.io/links. And if you share something related to the meetup today or whenever, just tag us on Twitter at Cloud Native Links. So the agenda for today, I'm starting with the welcome. I'm a bit late already, but then I'll pass to Alex and Yuri that will do the presentation on the Operator SDK. Then we have some time for Q&A, and we have planned to finish at 6:30, but let's see how that goes. As part of the Cloud Native Computing Foundation meetup groups, we follow the code of conduct of them. If you want to find out more about in details what is the code of conduct, you can take a look at this link here, or the QR code is there. But basically, everyone is welcome. It doesn't matter your gender or your skills or your nationality. And we want to have this community as open as possible. So everyone is welcome. And whenever you are addressing someone, please be kind. Basically, that's it in short. We have both organizers. I don't know if Jürgen is already here. I saw that he is, but I
Yes,
don't know.
yes, just in time.
Perfect. So,
Hey, Jürgen.
so basically, this community is maintained by myself. I'm a software engineer at Dynatrace. Here's my Twitter handle. If you want to know about the meetup itself, and mostly I just share things about this meetup. So here's my Twitter, and also my colleague Jürgen. Hello, Jürgen.
Yeah, hi everyone. Sorry for being a bit late, but also just making it in time for the introduction. So I was just jumping from another cloud native meetup, which is not yet an official cloud native meetup, but they are meeting today in Graz, and thanks to this virtual setup, I could join them, and now it's great to be here. So my name is Jürgen Etzelsdorfer. I live very close to Linz. I used to live in Linz, but now a little bit more on the countryside. Actually, I also used to work at Dynatrace, not in the same team as Giuliano, but also on very technical topics. And now I'm, since January this year, I'm the developer engagement lead for Austria at Microsoft. So if you have any questions around whatever your journey in the cloud is, then feel free to reach out. You also have my Twitter handle here. Yeah, I usually tweet about any cloud-related stuff. Recently, a little bit more Azure focused, but also a lot of CNCF. And I'm one of the maintainers of the Captain open source project. And this is also heavily driven by Dynatrace, and I'm still a maintainer in this project. That's also a CNCF project, and yeah. So that's me in a nutshell. And I think at the very end of the meetup, I will share one cool initiative that is currently going on. But I think we keep it to the end of the meetup, and I don't want to steal any more time.
Okay. So, well, if you want to talk or sponsor an event, so what is a sponsor of event? Basically, last last edition we had an in-person meetup, and then we need a company or a place to host that and also provide drinks and snacks to whoever is attending. That would be a sponsor. And if you are with some cloud native topics, please reach out to us and share with us. The idea of the community, as I mentioned, is to be open and welcoming, so you can practice your presenting skills.
Yeah.
And then like grow up in the talking world. So I have the links here, also in a QR code. And also, if you want to keep the discussion alive, join us in Discord. Basically tinyurl.com/CNCLinz-Discord. Yeah, so without further ado, now I'm gonna pass the stage to Alex and Yuri. They gonna do a tour of the Operator SDK, but I'll let them share what they have.
Okay, let me try to share my screen. So, can you see my screen?
Yep.
And I will
Good.
disable my video so you stay bigger there.
Okay, perfect. Thank you, Jürgen. Thank you, Giuliano, for the opportunity. Alex, it will be the first time on the meetup, the Linz meetup. I'm here for the second time. And before I start, my name is Yuri. I'm currently working at Red Hat in the same team of Alex. We work in an open enablement team. Basically, we try to figure out how to help our partners regarding different operators. Okay, then I will pass to Alex. Then Alex, please introduce yourself. Then we could start our tour of Operator SDK.
Hello, everyone. So my name is actually Alexandre Menezes, but you can call me Alex, which is way easier than anything else. So I hope everyone is safe and healthy at this moment. Glad to see everyone here. Happy to be here as well. I'm a software engineer working for Red Hat, and as Yuri said, like we basically develop operators and help partners on their operator journey, which is kind of an interesting way and a very effective way to automate workloads in your favorite cloud platform that is probably based on some Kubernetes distribution, right? So without further ado, I'll give the mic back to Yuri and let him just kickstart the presentation.
So thank you, and thank everyone again. And before we start our presentation today, I'd like to ask you some questions. Does everyone know what operators are? This is the first question. Let's throw some answers on the chat. We have time for it. Oh, Juliana at least knows what operator is. Oh, that's great. Anybody else? Okay, Bernard. Oh, great. Sounds great. Sounds great. Looking interesting. Yeah, Lawrence, don't worry. You will be know, or hopefully we will guide you to know what operators are, what the operator SDK is, and how could we handle things using both. And do you know what operator SDK is? This is the second question. Sounds great. Yeah, sounds great. Jürgen, nope. Didn't use the Operator SDK before?
No, I never touched it. I have heard of it, but I would need
Yeah.
to know this.
Yeah,
Okay.
I would go with Bernhard here. Like I have a rough idea of what is the operator SDK. Never used, so yeah.
Cool.
Okay. Okay. And how much are you familiar with the Golang? This is the third one, the third question before we start the meetup.
Right. Yeah, that's a big question. And is there
Yeah,
are there some Golang developers over
yeah.
here? Because I'll have to adjust my language a lot for that.
Oh, that's nice.
Okay.
Okay, but don't worry if you are not familiar with Golang. But if you are familiar with Operator at least, or if you have some previous experience in the Kubernetes, then you will be able to understand some topics. And please don't hesitate to ask us questions if you don't understand some topics, okay? Because we are trying to give you as much as possible content regarding operators. Then, everyone, I will tell you, I will start to tell you a story today regarding a friend. This friend is called Joey. Joey worked last year as a SRE in a big company, and Joey has to manage one MySQL application against a Kubernetes cluster, but he was struggling trying to automate some tasks like backups, restores, something like that. Then, during this process, Joey tried to find one feature or one way that he could manage this task in an easier way. Okay, then he discovered what operator or operators are. Then basically, operators are a way that we could automate some tasks in a stateful applications like databases in Kubernetes with the power of the Kubernetes controllers. Okay, then if we are trying to create a new operator, then we should use a way that could help us to create this operator from scratch. For that reason, we have here, or we trying to demonstrate today what the Operator SDK is. Basically, the Operator SDK is a framework that will help you in all steps, scaffolding the projects, scaffolding all the folders, files that will help us in this journey until you get the operators done. Okay, then Alex, please share your screen. Then we could start trying to do the first step, try to hitting the first step on the Operator SDK.
I guess you have to unshare yours for me
Yes.
to share mine.
That's true.
Yeah. Okay, now I can do it. Let me try here.
Yeah.
So
Let's present what Joey discovered last year when he tried to use the Operator SDK.
there we go. I hope everyone can hear can read that. Okay, go ahead, Yuri.
The VS Code?
It's a lot
Do
of
you want?
terminals, what we currently see.
Yeah, you see my terminal, right?
Yeah, right.
So I believe you want to
The
start
clean VS Code.
the clean VS Code.
Yes.
All right. So you have a clean VS Code, no files.
Yeah, no files. Then here in the backstage, we told Juliana that we will try to create an operator from scratch. Okay. Then
Right.
let's help us to create this operator from scratch. Then what we have, or how should we start creating our operator? Then the operator SDK abstract this power with one command. Then you can hit operator-SDK init, then the dash dash domain. What is the domain is? Basically is how you will place or how will call your operator group. Then Alex, please, you can name one domain. Yeah, let's call apps.com. Okay, then
Yeah.
go ahead. Take a look at the left side. You just got now some new folders like config and hack. And I will not go in deeper inside all these folders, but as you can see by name, default, manager, manifest, Prometheus, and so on. This is basically the first part of the scaffolded files related to the operator. Okay. After we do that, we should create one API. Then you can ask me, why API? Before you hit the comment, Alex, because operator creates a custom resource definition. Do you know what custom resource definitions are? Can you throw some answers in the chat?
I see one yes over there.
Yeah. Yes, we are trying to create this API because when we create the operator, we should create a custom resource definition. We have native resources in Kubernetes like deployment services, pods, but in that point, when we try to create a new operator, we should create a new resource or a custom resource. Then this custom resource we will call something like, I don't know, custom app or custom database. Then in our case, we will have to create this API and put all the logic that controller, that Kubernetes controller will act in this custom resource that we just created, that we just presented to the Kubernetes API. Then Alex, hit the command operator-SDK, then create API, then we should set group. Please wait before you hit the command, okay? Then version, then kind.
Hold on, my keyboard is lagging now. Just a second.
Okay.
I think I'm good now. Yeah.
Okay. Okay, before you hit the comment, are you familiar with the GVK concept, right? Then I guess you are quite familiar that we should start one new application in Kubernetes, putting the V1 Alpha 1 instead of to use the newest one, the higher one. This is V1. Okay, for that reason, we are trying to create our first operator. Then we will set V1 Alpha 1. Okay, then this kind will be called app with the capital A. Okay? Is everyone with me? I guess so. Or I hope so.
I am.
Okay, then hit the comment. And please be aware of the left side of the VS Code. Yeah, can you see that now we have new directories like API and bin? Okay, these new directories are really important because under the API folder, we will create the not the manifest, but the description that will define what it will be expected in our app, in our custom resource called app. Okay, then this is basically a Go script. Then I asked you if you are familiar with Go, but I guess it's pretty declarative. Then in the first step, we have the type app spec struct. What is the app spec? Do you remember when we are trying to create a manifest to be executed in the Kubernetes? Then we have the kind, we have the metadata, we have the spec, and we have the status. Then in this file, app underline types.go, we should define which fields should be placed on the spec, on the app spec. Okay? Then you can ask me why is presenting full? Because by default, the operator SDK plays this full just to give you an idea how you should declare the new fields. Okay? And another important thing, the operator SDK uses a logic of the cube builder of marks. Then, as you can see on the line 41 and the 42, we can see some marks plus cube builder object root true. That will help the operator SDK to handle the operator to create all the stuff required. Do you know the cube builder project?
Nope.
No?
Nope.
Yeah. Then Alex, if you we
I'll grab.
will drop
I'll,
out. Yeah, we'll drop out the link on the chat. Okay, then you can read some further informations.
Yeah, let me just share the link here. That should be the one like that you could use like to start your first operator if you want. So this is the Kube Builder book. There's a ton of information that will kind of make clear a little bit more clear what we are trying to present here. Go ahead, Yuri.
Yeah. Then below the app spec struct, we have the app status struct. That is really important because the controller will check the fields to act based on the information placed on the app status or in other fields. Okay, then this is basically how we could define the spec section, the status section from our operator. Okay, then you can ask me, okay, Yuri, we are creating a new custom app and a new custom resource in Kubernetes, but I'm aware that Kubernetes has one controller logic, one control loop logic, that the control loop check if there is an event that Kubernetes or the reconcile process should be started reconciling the custom resource. Then basically is when we have, let's say, one deployment, one replica. Okay, then you are working in selling products on the internet, and you have a promotion on the weekend. Then you have to scale up your application from one replica to 5 replicas. Okay, then when you set 5 replicas in your deployment, how the magic happens? Then when you set 5 replicas, the controller will identify there is a difference between the current state and the desired state, and will set one request to the reconciler to reconcile your deployment, creating new pods from 1 to 5. Does anyone understand that idea? I'd love to see some +1 on the chat. I'm afraid that I can be running a little bit complex.
Yes, I can help summarizing that when we step into the next stage.
I'm trying, Alex. Actually, I'm trying to put some marks here as a cube builder does, no? Just to
Sure.
see if the audience is interested enough in this presentation running into the operator SDK. Okay, then using this concept of the controller and the reconcile process, we should set our own controller to reconcile the custom resource. Okay, in that case, you can see that the message is pretty clear here. To do user, your logic here. Then you will set what your operator does if he has to be reconciled. Okay, then this operator has a replicas field or not, or this operator has some specific, I don't know, backup strategies that the controller should be aware of or not, or any special fields that you can use to the controller be aware of. Okay, then it's complex, but it's simple on the other hand, because we have to define the API and you have to put the logic on the controller. Okay, then we will start with Alex for now. Then he will start creating the logic in our controller. Okay, but the base idea to create a new operator is that.
Right. So taking from here, I'm not going to develop here because that would take a lot of time, right? But I do have an example operator that is quite simple in order to allow people to understand what an operator does. By any means, I want you to understand that an operator is supposed to manage what this one is managing, which is just a simple deployment. But with that idea, you can expand that to like complex applications where you may have multiple microservices running into multiple layers of distributed Kubernetes platform, or something like that, where you have backend, middleware, where you have the front end, multiple pods running. Some of them may be daemon sets, some of them may be just a deployment, some of them may be a stateful set. You may be willing to take care of storage, for example, may be willing to take care of external devices as well if you are connecting from your cluster to a cloud provider, for example, right? So this example is very simple. The idea here is just to get you a little bit of a taste of how it looks like working with Operator SDK. So getting a little bit, rewinding a little bit the tape and just getting everything that Yuri just said. Previous life is, okay, I do have Kubernetes. I know all those objects. I know like deployments. I understand pods. I understand my applications need to go there. I understand that I need to put services in place. I need to use sometimes ingress controllers. For some applications, I may even use some sort of service meshes to make things work smoothly the way I want. So you're kind of adding up to the platform and getting creative. But there is a moment where you begin to automate some stuff that is out of that scope, and then you begin to see scripts coming in. So how do I optimize something? How do I, for example, do my backups and do backup testing? How do I, for example, can react to some metric in a very specific way that there is no tool out there that can do like that? Once you kind of package all of those tasks that are very special together, you do have some very unique set of knowledge that is representing your specific workloads, your specific deployment to a certain service or product. So it is very specific to your situation. So you name that thing, right? You say like, this is my product. In our case, like it's just the app concept, right? So then the question that is always in the mind is, what if that whole thing can be just another Kubernetes object? And here is exactly how we use CRDs. We build a custom resource to make that special, specific, unique application that we are um, serving our communities, our people with, and we get exactly that modeled on a CRD with the parameters we want the user to actually point out there. Okay, so an object is just an object. If you understand Kubernetes, you understand that a CRD is just a piece of data that we register by using the Kube API server. We register in etcd, right? So, okay, so then we have etcd registering that information. Okay, um, but what actually is going to get that information and make the real world, and the real world may be anything, maybe all those Kubernetes objects that we know, but configured in a certain way, maybe some resources out of the Kubernetes scope, and for example, cloud services, cloud databases, cloud like key management systems, cloud user like management systems and other stuff, even billing, accounting, and all of that, you can put together in an operator as long as the operator has the proper credentials to do all of that, and the proper network access to all of that. So then you need to kind of have in one side your desired state that is described in this new object that we just created. In the other side, we do have a controller. The controller is basically an infinite loop that will be watching those resources. What happens is that Kubernetes controllers, and especially Kubernetes API in general, or if I can pinpoint directly the API machinery project that you can see here imported multiple times into this project, it is probably responsible for 80% of Kubernetes code. So what you see inside of this is highly complex. There is a very steep learning curve to understand what is inside of this. I've been like 2 years in with operators or more, and I still don't get everything. Like there is a lot of code in there that is very, very complicated. So what Operator SDK does is simplifying all the controller stuff and all the CRD stuff into a very cool method, which is what we just did. So then we initiated a project, just a basic project. Then we created an API that has as its other counterpart a controller. So here we have an API, right? And we have the controller. So those folders, they are created after the Operator SDK create API command, right? So when I do that, and I create those APIs, it will scaffold some Golang code. Now let's understand how those pieces fit together. First of all, for those who are not Golang developers, when you run a Go program, you got to start at some point, somewhere, right? So the Go program starts on the main package, right? So you're normally going to have a main package. You're going to have a main function. And here in the main package, everything is going to start for the operator. So what happens in here, in a very summarized way, is that the binary that gets out of this code is starting what we call a new manager. So a manager, remember that Kubernetes control plane has something called controller manager. So this is your custom manager. Is the guy that will run a controller for you on behalf of your application. So when the manager is running, a controller will be put in place. But there is one problem. You are informing the controller what API you want to watch or what object you want to watch. So the controller will be watching for events on my app that has a spec, it has a status field. I'm going to talk a little bit about this in a moment. So the controller will be watching for that, but the controller doesn't know how to react when an event comes in. what is that event? An event may be an update, a delete, a create. Something happened to that object. It creates an event, and the controller will trigger a new work by putting that work on the work queue, what we call a work queue. And the work queue is supposed to trigger a function, a special function, and that function is what we call the reconciler. So the reconciler is the function that has like the unique goal of reconciling, doing the reconciliation between the desired state and the actual state of things, right? So when you use Operator SDK, what happens is we just scaffold all that code, and the only thing you need to tell, basically, there is a lot of tools here for testing. You have a bunch of manifests on the config, but the main things are you need to define how your CRD will look like in Golang type, in Golang language, right? And how your controller will behave when an event happens to that object. So when you have both things in place, you just tell, hey, manager, here's what you're going to set up in your controller. Every time something happens, please call this reconcile function. So that's how things happen. So after scaffolding everything, doing a quick rundown on those folders. API folder has your main CRD Golang type, right? The bin folder is where some binary generated by the automation will be placed. Like controller gen and customize are two tools that are used by the project, and you can find how the project is using them on the make file. There's a lot of targets on this make file, right? Then you have the config folder, which is basically all the manifests that are used to deploy this operator. So coming back to the concept of an operator in some sense is just a binary that runs a controller. They can talk to Kubernetes API. And how do we run that binary? We run that binary inside of a pod, and that pod has a ton of special manifests to handle that. So you have like you have the manager, for example, where you can see the deployment for your operator and how it is scaffolded out as well with its metric endpoints, limits, haversack count, everything else. You have, for example, the RBAC, everything that is related to that specific deployment. So what kind of permissions that operator needs to have, right? And you will have a ton of other stuff, including the CRD. So to generate the CRD, we normally use make generate, after that make manifest. So the command make manifest that is in the make file is the one that generates a ton of those YAML files for you. And when do we run those commands? We run those commands after we put together an object here that can be translated into that CRD. Every time you change the app types.go, you got to run make generate and make manifest in order to have everything correctly placed in the YAML folder. So you will have everything that you need here. That said, so we have the spec fields in here. What I'm doing is just let's say that I'm just I'm just creating a spec to manage a deployment, and it doesn't make any sense managing a deployment, but it's nice to understand how it works, right? So I do have those fields: image, command, args, and replicas, right? And I created some phases as strings, very simple ones, to say creating, running, or terminating. And then I have my status field that will actually take one of those phases that I've just created here, right? So from there, we go to the controllers, and let's take a look at a really high level here. I don't want to go too deep into the code, but I'll just mention briefly some of the most important steps that you want to have. And this is why it's very simple, that you want to have when creating an operator. So the reconciler function is actually tied to a struct. And when you see that struct, it has two very important things. And the one that you are going to use the most is this one, is the client. So what happens? Operator SDK is based on KubeBuilder, So Operator-SDK has a ton of other tools that wraps around KubeBuilder, but the core is KubeBuilder. And Operator-SDK and KubeBuilder are based on controller runtime, which is part of Kubernetes SIGs, right? So controller runtime will appear here tons of times, right? And with controller runtime is based on API machinery. So you have a layered approach, but controller runtime has a very opinionated and very simplified client that allows us to talk to the Kubernetes API, right? So in brief words, what this reconciler is doing is setting up a log, right? When, remember, the control loop is running, an event happened, and then the control loop just decided, okay, I need somebody to call the reconciler. So it's called, the reconciler is called, the manager calls a reconciler. It will pass a context with some very brief amount of information on a logger, in the logger, and a lot of stuff, and a request. It just identifies which object needs to be reconciled. Just that, not more than that. So there is not a lot of information here. So you gotta understand what is happening behind the scenes, right? So from there, we just set up a log. Now I have a logger, right? Then I need to define here an app object, which I just defined on type, so I can actually I can actually load that guy in memory, right? So with an empty, this brackets or braces that you see here, it's just a way of saying, hey, I want a literal object of this type. It is a pointer, and I want this guy just to be an empty object. I just want the type. Then I run from the reconciler a client get operation, because I want to get the object that actually triggered the whole event, just to make sure on what is the desired state and be able to compare with the actual state of things. Then I do that get, I pass the context, I pass this variable that is basically the request itself, and the namespace name object, which is another thing. I don't want to go deep into that. So then we have like the app itself, which is that object. With that, we have a call to the API. The API will respond to that. We'll get app as a pointer filled in with whatever it finds. If it finds nothing, like let's say that we have an error with this call, nothing is there, then I'll check, is it a not found error? Okay, if it is, somebody deleted the object, I don't need to reconcile anymore. I just return from this function with no errors. For those who are not familiar with Go, new is the same as null, so it's nothing, right? So and then if it is some other error, then I need to report the error. I actually need to requeue the work. So I'm returning with the result saying, hey, requeue this work, please, because I need to reconcile this. And I return the error for it to be logged by the upper layers, which are in the manager itself, right? Okay, that said, let's say that no errors happened. So I got an object. I just update the status. I see somebody, multiple return types. What is that, Jürgen? Is that good or bad? I hope it's
Yeah,
good.
it's good. It's good. No, I
Wow,
was
cool.
just saying that because you mentioned that it's a status and like or nil, and like it's in Java you don't have this concept, and in Golang you have it. So it's really cool that you can return multiple.
Yeah.
Gotcha. Yeah, so here I'm just updating the phases. Remember, I thought that I can actually say status phase, and I can update the phase by using another call to the API, which looks like this, right? And if I go forward, okay, so now I'm creating something, or I'm initializing something, and then I can go further and create what we call the object meta for that specific deployment. So like a name plus like a suffix with deployment, namespace, some labels I could put in there, and then after setting up the object meta, I have a function to actually create that deployment for me. Then what does this function look like? Pretty much like a YAML file, right? So if I go to the deployment.go, it is a literal object, nothing else. The cool thing about this object is actually, since I am passing app, which is that type we defined here, I can actually fill in the fields. So I can get image and say app spec image. That's the one the user put on the CRD. App spec command, that's the one the user put in the CRD. App spec args, and so on and so forth. And the replicas should be here somewhere, like here, for example, right? So that's pretty much what happens in this function. It fills in the object as apps v1 deployment, creates the object for me, and returns it, right? The cool thing, it sets the controller reference, just telling Kubernetes, hey, the owner of this deployment is actually that controller. It's not a normal deployment, right? Which is important because with that, we have garbage collection. If we delete the CRD, the deployment goes away, right? So then going back to the app controller, then what I do here is pretty much like what we should do here is pretty much like, okay, get the object, get the deployment then, and check if this guy already exists. If it is not found, create. And if it is found, then check, for example, some field. I want to check replicas. Check if it is equal. Okay, somebody changed the replicas, so I need to update. And that's pretty much what we do, right? After that, I can run status phase again and simply update the status for the CR itself, right? So real quick, what happens if I try to actually run this operator in front of you? I hope it works. So let's see. OC
And
commands, because I have an OpenShift cluster here. Yeah, go ahead, you.
yeah, no, it's just to add a comment that you are just showing the magic behind the scenes of Kubernetes. you
Yeah,
are
kind of.
you are
Yeah.
just describing how the scale up, scale down happens. In Kubernetes.
Yeah, for a controller. Yeah. If you change a parameter, it would be like that. So I have no app CRs, right? I have no objects called app here, right? So what I'm going to do is a different way. I could run make run, which is a target that we see in the make file. You could use it. It's basically running go run and something else using the go itself. What I love to do, and some people will really appreciate that, is I love to use VS Code debug stuff. So I could just click on the main file, click inside the file, make sure it is in focus, and I go to run and debug. When I run and debug and I click here, it starts the control loop, the manager, and everything, and it spits out on my console here everything that I need to know in order to develop this. So imagine that I'm developing something from my laptop. So right now, this guy is connected to an OpenShift cluster in AWS and connecting and talking to that, right? So what I'm going to do now is to show one of the generated files in the config, which is pretty cool, that I can fill in after building my CRD, which is samples. You go config samples, and inside the config samples, I have one sample of that CR. How does it look like? So what I did is I put an image that I normally use to do network troubleshooting, for example, and I said, okay, run just bean bash and make this deployment just as live. Let it running, right? And I want 3 replicas of this guy. That's my YAML file that is created automatically for me. I just need to put the fields in and the values, right? So after that, I can actually say OC apply. It could be kubectl apply as well if you're running another distribution of Kubernetes. And then I could say just config samples, and after config samples, I can run apps v1 alpha 1, and boom, it created something. So now I should, first of all, I should see something coming up on the controller is actually doing a lot of logging. And I should say OC get app, which is an object that doesn't exist in Kubernetes. Now I have an app sample guy, so which is the one I just named. So if I say OC get app dash sample, right? Let's, oh, not that one. OC get, not OC get, OC describe and app sample. It should give me exactly what I gave it. So the spec field is here, replicas and everything else. Phase says running. So if it says running, I should have OC get pods, and I should have 3 replicas, right? One of the things that we can try to do, and we got a few problems yesterday with that. I don't know if it's going to work well, which is OC did app sample, right? And then I open on my Vim terminal here. I go back down and I change replicas, who knows, to 5, for example,
Let's
right?
cross our fingers.
Yeah, let's see if it's gonna happen. Got it. Yeah, so then we added that thing. I believe some more logging should be coming out, and OC got pods, and I have 5 pods running, right? Some with more time, some with less time, right? I could scale down, but for now, I'm just comparing this field. If something changes here, it will trigger an event, but it will see that the replicas are the same. I'm not changing anything else, right? So this is just a very short example on the steps on what you need to do after opening Operator-SDK for the first time and building an operator. After that, you have some commands such as make build that will build your operator container from this Docker file that is provided with the project. And after building and pushing that, like I think it's make build, make Docker build, make Docker push, or in some cases, depending on the platform you're running, it may be podman build and podman push. And after you have that container already staged into some registry that you can access, you can run make deploy, and that same code that you see running here in live mode would be running inside a container, inside a pod deployed in your cluster. So instead of using my kubeconfig credentials to talk to that cluster, it would be using a service account token that it would reside inside of that specific container. So I guess it covers kind of the umbrella of what are the tasks that we kind of need to pinpoint. There is a ton of other things, like we can build bundles, we can build testing, we can build a lot of stuff with Operator SDK, but this is kind of the core of Operator SDK, and it kind of pictures how easy it is to build an operator if compared with something from scratch where you actually need to import the Kubernetes API machinery project stuff and build yourself. Then you have to deal with like informers, caching, watching, a lot of listers, controllers themselves, and all of that stuff, right? So I guess that wraps up what we had to present. I hope I didn't pass too much the time. We could go deeper into this code and begin discussing a lot of stuff. And I would be very, very glad to see some questions coming in.
Yeah, and just a reminder, when Alex applied the manifests in the OpenShift cluster, these manifests got created using the make manifest command, okay, that Alex mentioned some minutes ago.
Yeah.
Then if you run the make manifests, they will take place with the right manifest to be applied in your cluster, okay. Just let me share my screen.
Let me stop sharing then. And I'll just say one more thing. This is very, very simple. You gotta work with your imagination. Okay, what if I don't have only deployments? What if I have deployment services, demo sets, and a lot of other stuff, and maybe external things like cloud services or even devices? If you're running bare metal, it could be a switch, for example, a router or stuff like that. So you could actually, with the proper credentials and the network access, you could manage a lot of stuff.
And to finish our presentation, I have to be honest with you that Joey, my friend that I start talking about him in the beginning of our presentation, it was actually me last year struggling with some MySQL databases. Then I discovered the power of the operator and the Operator SDK. Thank you, everyone, for our
Thanks a
time
lot.
today. Thank you, Alex, Giuliano, and Jürgen for the invitation. And yes, I'd love to see some questions on the chat. Please don't hesitate to contact us. I will, as you can see, we have some contact details here. I don't know if it's a little bit small, but we can drop on the chat. And yes, that's it from the Operator SDK.
Awesome. Thank you very much, guys.
Thank you. Thank you.
That was super cool. I don't know if we're gonna have any questions from.
Maybe I can kick off with a question. And thanks so much. It's wow. It was wow. It was
Thank
so
you, thank
much,
you.
also in detail, and then maybe I got lost. That maybe you mentioned it, but I was wondering, like with the operator, if I'm only interested in some specific parts, like failed deployments, let's say, or is like where do I specify which events or which information I'm interested in the operator? Because like in Kubernetes, you have a lot of events going on, and not each event might be of interest for each operator.
Got you. So yeah, one of the things that we need like to clear out is that we do have this concept of operator coming up, like I think it was 2016 or something like that at CoreOS. And the idea of an operator in an operand, so the operator managing an application and bringing that human knowledge into that is something that is quite repeated among like operator framework folks and all of that. But if we really abstract that idea, operators are nothing but like an extension of Kubernetes. So you can do anything you want with that. Even a full application that we wouldn't call an operator, but something that actually has uh, everything that you need to actually put stuff together. So answering to your question, where do you actually set up or register something to be watched? It will be some. If I can share my screen, Yuri, just real quick.
Sure.
Yeah. Let me put back in here. So the default way to do that is actually when you go for controllers. For example, I'm building some deployments, right? And my deployments are owned by my controller. I can say set owner here instead of controller reference, and then the owner would be some like app is the owner in this case. So the app is owning a deployment, right? I guess what you want to see is probably events from other objects that are not necessarily owned by the specific operator. Is that what I'm getting?
Ah, okay. Yeah, I think I'm now getting the connection here. Yeah.
Right. Right. You know that there is an owner field. This thing is particularly interesting when you're building an operator because you can set controller reference. Then the controller app, the CRD app, the object app becomes the primary resource, while the deployment becomes the secondary one. So by default, if you delete app, like I'm going to show you here, so and remark that it is I'm not running the controller right now. I just stopped my debugging session. But if I say OC get pods, I should, it's a little bit slow, but I should see the pods there yet, right? So if I go in OC get app, for example, and I say OC delete app simple, right? And immediately I ask for OC get pods. Let's go. Okay, they are terminating. See? This is garbage collection that comes by default or as a gift from Kubernetes API because it knows the owner was app. So since the app got deleted, everything that is a secondary object needs to get deleted as well. So with set controller reference, I do two things. I actually set the owner and I say, hey, the controller is this other guy. If something happens to the secondary resource, please notice the controller, send a notification. And then the controller, when I go to the controller itself, how the controller is being set up with that manager. There is a function that we create here with the reconciler called setup with manager, and I pass in the manager as a parameter, and I have something called owns apps v1 deployment. So then it begins to listen to deployments as well, not only for the app CRD. And when something happens to that deployment, okay, I need to act on that. I need to reconcile that as well, right? So that's kind of how it works behind the scenes. But like
Translating. Sorry,
the
Alex.
actual library, yeah,
No,
the actual
translating.
library that is
Yeah,
doing
sorry.
that.
Go ahead.
I will just say that the library that there is actually behind this is controller runtime. So then controller runtime is a big project. We have no time to go into that. But if you want to dig deeper, controller runtime under Kubernetes is the thing. Kubernetes 6 actually is the thing you want to take a look at.
Also, I was just
Thank
saying, translating to the native resource, that is exactly what happens when we change something on the deployment. Then the replica set controller will act somehow. Then the replica set will effectively work in the pods. Basically, is that.
Cool.
Yeah, I
Thanks.
hope it answers kind of your question.
Yes, it does. It's
Okay.
just a lot of this is new, so I'm happy that I can read a little bit of Golang. But it's and maybe just another question while we're. If someone else has a question, please just jump in or drop it in the chat, and I'm happy to forward. But just one other question, like, are you currently working on some kind of operator, and what is like the best scenario where you would see a fit for an operator, like not a hello world, but like where you see a lot of operators that are built in one specific context?
So if you get, for example, something like the Azure operator that
Or the
automates
OpenTelemetry
all Azure
operator.
services, or the OpenTelemetry, or something like a Kafka operator that can actually manage a full cluster and like upsize, downsize stuff, or something related to Spark, for example, processing stuff. I've been seeing a lot of operators doing low-level stuff because I work more on the networking side of things. So operators that are managing hardware, for example, not only GPUs for data science, but also special network interface cards where you can actually process packets in a different way and virtualize network functions. Have what we call it CNFs, which are container network functions running on top of those, and having dedicated network interfaces for specific pods. So there is a lot of dancing to do to make that work with a Kubernetes, any Kubernetes distribution. And still secure that and have everything like smoothly running. So an operator comes down to that. So if you look at OpenShift itself, the philosophy is so widely adopted that if I just go to OpenShift here on the terminal and I say OCGAT, I would say cluster operators, right? So this is just the list of the operators running by default on a freshly installed OpenShift cluster. So we have bare metal stuff if you're running bare metal. Cloud Controller Manager is an operator that actually configures Cloud Controller Manager for you. So you have like an operator for the console, an operator for configuration, for example. Kube API server has an operator to change information on the fly on the Kube API server if you want to troubleshoot stuff. Machine API can allow you to change things for the machines themselves. Like a machine config operator is the one that actually changed low-level stuff, configuration on the nodes, and so on and so forth. The network one, for example, you can configure pods and stuff like that. So when you run OCGAT cluster operators, you see a ton of those. That's because there is a lot of things happening using operators to make the platform a little bit easier to manage.
Yeah. If I'm not wrong, Dynatrace has an operator.
Yes, you're
Yeah,
right.
yeah, I believe so. Yeah, that's right.
Yeah.
Yeah, actually, I got a question.
Oh yeah.
Go ahead.
Can an operator use another operator for doing his stuff, or is this a thing I should rather not do?
Yes. So you have two concepts. One is the meta operator concept, which is something that we don't encourage people to do, but sometimes it's needed, which is having an operator that manages other operators by itself. So this is all coding and hacking, doing a lot of stuff. And the other one is if we're using, and then if you go under the operator framework, we have Operator-SDK, which is a big project, but we have another one, which is the operator lifecycle management or manager. Operator lifecycle manager is the guy that actually kind of can manage all operators for a particular platform. So with that guy, you do have the option of having an operator that depends on another operator. So you can declare your dependencies. So I'm running this application, I'm managing this application with this operator, but this application actually needs, let's say, a special database for something. Then I actually declare that I need the operator for that database, and they will get installed together the way you want, right?
Oh, cool.
So this is another way for using multiple operators at the same time.
Yeah, right.
So they know the dependency, and that's fine.
Yeah, exactly. You can kind of manage the dependency there. Yeah.
You can.
I actually got a second question, which is the operator is just running on a pod, if I understood correctly.
Yeah.
Is it possible to use another framework like Java or .NET or something like this to write the operator, or is the SDK just for Golang?
Yes, as long as you have a client on whatever language you want, you can build an operator. That will
Okay.
be a very painful task.
Yeah,
but you
I
can.
think so. Because it would be more popular.
The good news is we do have right out of the oven Operator SDK for Java,
Cool.
and very close, very soon, Operator SDK for Python. So that will be like that. Like if you have Go, Java, and Python, man, you have whatever you need, right? So you can choose it. But yeah, Golang is probably the language that has more features and libraries available for cloud native stuff. If you're like building from scratch, is a very fun language to learn, and it's very effective if it is from scratch. But you have something already in Java, or I have partners that are actually working with Java operators, and it works as well. So it's not a big deal. Yeah.
Or Helm-based operators or Ansible-based operators. If you have a Helm chart, then you can start.
If you want to go real quick.
Yeah, if you have a Helm chart, then you can start operator based on your Helm chart.
Yeah.
It will be another
one caveat though is that Helm charts can do basic install and updates, right?
Yeah.
And you stop there. Ansible, you can do a lot of stuff because you can aggregate scripts and language inside Ansible, but then your project becomes more complex. And if you run in pure Go or Java or Python, you can go up to what we call the autopilot phase, where you begin to stack. Because here I'm just installing something and showing how to connect things together, but you can go further. You can have an operator that is aware of how to upgrade an application without disrupting anything, without making any mess with sessions or anything like that. I can step into like lifecycle management by doing like some sort of like backups and disaster recovery stuff automatically. And also I can go even further to deep insights, grabbing up metrics from all the operands, and go even up further by using autopilot and reacting to those metrics in order to manage something like that is failing, for example. Okay, that is failing. Why is it failing? And I observe some metric. Okay, what I need to do is to do something in the configuration that will become normal, or I just need to restart a pod or something like that, right?
Awesome.
Yeah. A lot of concepts, right?
And thanks for the questions.
Yeah.
Yeah, it's kind of intense. Yeah.
Yeah.
Okay, I think if we do not have any other questions, I'm gonna pass to Jürgen. I think Jürgen, you wanna share your screen, right?
I have a lot of different tabs open. If I find the right tab,
I can share.
You just if you can just bring slide number 10 on the screen. That's the only thing I need. Thank you. Because I looked up a couple of things in the background, and now you all know that like all these tabs. Yeah, thanks. So just if anyone is interested in at Microsoft, we just launched a couple of days ago. It's kind of fresh off the press, the blog article that we launched, the Spring Skills Challenge. If anyone is interested in doing some kind of cloud skills and also getting certified in a sense that we have the Spring Skills Challenge, and you can sign up here. I will also put it in the chat if you're interested. I can already say it won't go in this level of detail as we just saw. So it's not as technical, by far not as technical as what we just learned. And I would say if you're kind of starting in the cloud, if you're interested in how different clouds work, especially this one is for the Azure cloud, feel free to have a look at this. And why is the backpack here? Because if you finish one of those, you don't have to go through all of those. But if you finish one of those, within a specific time frame, I believe it will be the end of April, but you will find everything in the blog post. I will just drop it here, and that was the only thing I wanted to mention. So if anyone's interested in this, give it a try. And yeah, I just want to thank everyone that joined for today, especially the speakers. So really cool. Thanks, Yuri, and thanks, Alex. I believe that, Juliana, you mentioned it also in the beginning, that we are now migrating from meetup.com to the official CNCF platform. So you will find us on actually the place where we also meet today. So community.cncf.io/linz, I think, is our chapter.
Exactly. Yes. That's the chapter, but I can put it back here. Yeah. Cool. And I mentioned, but everyone that is in the call, they already signed up, because there is no way of joining without signing up.
Okay.
But as we are recording, then makes sense to highlight that again.
Yeah.
Cool.
And if you know others that sometimes join our meetup, or is like in your some of your peers, please let them know, because meetup.com, they might remove us sometime if we don't catch up with the payments. And actually, we're stopping the payments now for meetup.com as we're moving to the official platform. So we might sometimes disappear on meetup.com, but we still exist on community.cncf.io.
Yeah. Cool. I'm gonna just reiterate Jürgen's thanks. So thanks, Yuri. Thanks, Alex. It was super cool, the deep dive. It wasn't even though the app that you guys shared was like a simple app, what we got was a lot. So
nice
for
to
that.
hear that.
Yeah.
And,
thanks for having us. Yeah.
Hope to see you. Well, Yuri, I'm sure I'm gonna see in Valencia. I'm not sure if I'm gonna meet you there, Alex, but yeah, I'll be at KubeCon, so maybe we can grab a coffee together.
I don't think I'll be there. Yeah, but if someday I go, I'll let you know for sure.
And of course, if you're coming to Austria, please visit us in Linz.
Cool.
Be glad to have you here. Hopefully you come in a day or which the weather is like this in the picture. So
right. You don't know how it is here. I have more than 2 meters of snow in my front yard. So here is no joke.
It's unbelievable, right?
Yeah.
Awesome. So I'll just stop the recording. Thanks everyone for joining.
Thank you.
Thanks everyone.
Yeah.